Okay, we're going to continue our discussion on characteristics of polynomial with the addition of something called a degree. Now, we've talked about degree. Degree is the highest exponent in the polynomial, but the degree tells us a lot of information about the polynomial itself. Probably most important is it tells us the number of zeros, otherwise known as x-intercepts. And so this tells us basically how many answers we're going to have, or how many times it crosses the x-axis. Probably the most important thing we can find out about the polynomial. The degree also tells you the number of directions. So for instance, if we have a parabola, so let's just call this x squared. X squared. We have a parabola. Okay? So we know that this parabola across the x-axis 2 times based on the degree. The degree is telling us it crosses twice. And it also is telling us that it has what the maximum number of directions. So it's going down here, but it's going up here. So that's 2 directions that it's traveling in. So it's 2 directions. So that's the maximum number of directions that it can go. Also tells us that if we subtract by 1, the maximum number of turns that it has. So this n minus 1 tells us that it's going to turn 1 time. Because the degree is 2, we take 2 minus 1, that's going to equal 1 turn. And so what it's doing is it's going to be going down, it's going to turn 1 time to go up. So you have a turn right here at the bottom. Next up is minimum and maximum values. So I have 2 graphs down here at the bottom that I want to visually show you minimums and maximums. So maximum is going to be a really big thing, and a minimum is going to be a really small thing. So we have things that are called absolutes, and we have things that are called relatives. So absolutes are going to be the most highest or lowest point of the graph. The relatives are going to be little bumps in the road, peaks and valleys in the middle of the graph. Okay? So just to kind of give you some reference here, this right here is an absolute max. But we also have another high point of the graph right here, so this is a relative max. On the right-hand graph, these 2 are also absolute maxes, because arrows will go up forever. Okay, so those are maxes on the graph. To flip that around, we have low points or lowest points on the graph. So over here on the left, we have what's called an absolute minimum, because nothing goes lower than an arrow that's going down. But we do have a low point of the graph, so this is called a relative minimum. And on the right-hand side, there is no point lower than this one right here, so this becomes an absolute minimum. And there is no relative minimum. So this graph on the right doesn't have a relative minimum, but it does have an absolute minimum. All right, let's fill in the blanks. All right, so we're talking about the y-coordinates and the turning points of the graph. The absolute maximum is the highest point. On that graph. The absolute minimum is the lowest of the graph. So there is nothing higher, there's nothing lower than an absolute. The relative maxima is found at the top of a peak. So here, this is the peak of like a mountain, and so that becomes the relative max. And the relative minimum is found at the bottom of a valley. So down here, this would be the bottom of a valley down here. This would be a peak. Right there. Minimum and maximum values are also called extrema. So you're going to hear us call these extrema. And that's relative min. That's the minimum and maximum values of polynomials. Okay, let's check out some examples of those things that we were just talking about. So we were talking about degrees, we're talking about extrema, mins, maxes, things like that. So what it wants us to find is what is the degree. Okay? How many different directions is this graph going in? How many times does it cross the x-axis? So there's two different ways for us to determine that. So 1, 2, 3, 4 times it crosses the x-axis, therefore the degree equals 4. Now I'm going to do that another way. How many different directions is it going? 1, 2, 3, 4. So directions was 4. So either way, it told us that the degree was 4 for this problem. On the B problem, how many times does it cross the x-axis? 1, 2, 3 times. So really what it should say is x-intercepts equals 3. So back here where it says degree, it should really say x-intercepts. And then directions, 1, 2, 3. So either way, you'll see that the degree for the problem is found in two different ways. So we have a degree of 4, and we have a degree of 3 for each problem, A and B. Find the least possible degree, count the number of extrema, that's the number of terms, and we're going to add a 1. So how many times does it turn? So these are the maximum minimum points. The extrema, remember? Extrema meant minimum or maximum. So how many extrema are there? 1, 2, 3, 4. So there are 4 turns to the graph. So we're going to take 4 plus 1, and we're going to get a degree of 5. So the degree in that problem is 5. So that's how we figure out the degree based on the graph. All right, example 2. Figure out how many turns this has. So extrema means turns. How many turns does it have? And so we talked about this when we talked about degree. We'll take the degree and we're going to subtract 1. So the degree in each problem is the highest exponent. So that would be, oops, sorry, did not write it in. That would be 3 minus 1, which is 2 terms. 4 minus 1, which is 3 terms. And 5 minus 1, which is 4 terms. Now we're talking about end behavior. In other words, what are the ends of the graph doing? So if we were to take a look at the graph that's down here, we would say, most of us would say that the graph is going up and the graph is going down. Well, what we want to say is rather than it goes up, that it's going to positive infinity, or if it's going down, it's going to negative infinity. So we're going to use the words infinities here to answer a question. So what we're going to do is basically just look at the graph. Okay? But the hardest part here is going to be reading the graph itself. So what we want to be able to do is understand that this is telling us that we are looking at the right side of the graph, and this is telling us we're looking at the left side of the graph. And so we read this statement as x approaches infinity, f of x approaches, and then we get to fill in the blank. Oops, don't want to get rid of that. So we're going to answer these questions with either a positive or a negative infinity. So again, this is the right side, this is the left side. So this is the right-hand side of the graph. So as, I'm going to kind of like underline this as I read it. As x approaches positive infinity, that's the right-hand side, what does the graph do? And so we've already discussed that this graph is going to positive infinity. You don't have to put the positive on it, okay? So over here, that's the left-hand side of the graph. And so we've already discussed where it's going, that it was going down to a negative infinity. So we will read this as x approaches in negative infinity, f of x goes where? And so we've decided, based on what the graph looks like, that it's going to negative infinity. Again, the hardest part of this is the written part of it. What is it reading? So we really need to understand that this is the right side and this is the left side. And then after that, we're just going to read the graph. Is the graph going up? If the graph is going up, it goes to positive infinity. If the graph is going down, it's going to negative infinity. Okay, let's look at some examples of end behavior from a graph. So a couple of things here just to remind you. This is the right side, left side. Right, left, right. You can see the left, but I'll speed that up. Left, right, left. Okay, let's go through. This is our right side. Okay, which is going down. We say that the right side, when the right side is going down, it's going to negative infinity. Anything that's going down is going to negative infinity. Okay, over here, this is our left side. It's also going down, so it's also going to negative infinity. It is possible that both ends go to negative infinity. Okay, example B. Here is our right side. It is going down. So it's going to negative infinity. This is our left side. This is going up. Anything that goes up is going to positive infinity. You can put the positive on there. You don't have to put the positive on there. That's personal choice. On example C, this is our right side. This is going up. The right side is going to positive infinity. The left side is going down. Therefore, it's going to negative infinity. And the last example, both of them are going up. So both of them are going to positive infinity. Okay, and then we can also determine end behavior based on the polynomial itself. So all we need is the leading coefficient and the degree. And those two things are always together. So the leading coefficient and the degree. So if we have a polynomial, you'll see examples A, B, and C down below. These are the information. I'm going to recolor code that. So our leading coefficient is -2, positive 1 is positive 6. Our degrees are 3, 4, and 5. So we can tell the end behavior of a polynomial, what the graph is going to do, based on the leading coefficient and the degree. So the leading coefficient tells us what the right-hand side is going to do, and the degree is telling us what the left-hand side is going to do. Alright, so I'm going to reiterate from earlier that this is the right, this plus, when x goes to positive infinity, that's the right side, and when x goes to negative infinity, that is our left side. Remember that our answers here are going to be positive infinity or negative infinity, okay? So when the leading coefficient, so we're back over here to the leading coefficient stuff. When the leading coefficient is positive, the graph is going to go up. Okay? So when the right-hand side is going to go up. And when the leading coefficient is negative, the graph will go down. Remember, that's the right side of the graph. The degree is telling us what's happening on the left-hand side. And so degrees can be one of two things. They can be even numbers, or they can be odd numbers. And so when it is an even number, it's going to do the same as the right side. And when the degree is an odd number, it's going to do the opposite from the right side. Okay, so the right side is important. You got to know what's going on the right side to understand what's going on the left side. So I'm going to jump down here to these examples. And so we have a leading coefficient right here. The leading coefficient is a negative value. So the right-hand side is going to negative infinity. The degree is an odd number, so it's going to do the opposite from what the right-hand side is doing. And since the right-hand side is going to negative, the left-hand side is going the opposite direction, which would be to go up. Okay, so that's example 1. I'm going to get rid of all those things that I circled and that I pointed to. Actually, I'm just going to leave those. All right, we'll get over here to the leading coefficient. The leading coefficient on B is 1. That makes that a positive value. And positive values, the right-hand side, go to positive infinity. Moving to the degree is an even number. So the left-hand side is going to do exactly what the right-hand side is going to do. In this example C, the leading coefficient is a positive value. Therefore, the right-hand side is going to positive infinity, and the degree is an odd number. Therefore, the left-hand side is going in the opposite direction. So that is end behavior from the polynomial. Okay, let's put all this together. Given the polynomial and the zeros, sketch a graph and determine the characteristics. Let's put it all together. So let's check this out. Let's see how many zeros it was. so look at answer some of the questions on the bottom, and we'll kind of go up and we'll play with the graph, and we'll see what happens. All right, it tells us we got 2 zeros, so there are 2. Okay, that's pretty simple. Max number of extrema. Well, if there's 2 zeros, it's n minus 1, which is the degree, minus 1, meaning it'll have a single term based on the leading coefficient in this graph. The leading coefficient is positive. The right-hand side is going to go up. The degree is 2. So, therefore, it is even. It's going to go in the left-hand side is going to go the same direction as the right-hand side. All right, so there's one thing I did not answer here. I did not answer the y-intercept. The y-intercept is the constant of the graph. So we know it's going to cross the y-axis at -20. All right, so let's put all this on the graph and see what it looks like. Now, we're going to estimate a little bit because the numbers are kind of big. So we're going to say that 1, 2 is there, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is out there. And 20 is going to be, well, let's see, that's -10, then -20 is way down here. So we're going to say that it crosses at -10, +2, and -20. This only has one term. Remember, it's one term. So when it says that the right-hand side is going up, the left-hand side is going up, it's going to come down, it's going to turn somewhere around this 20, and get up. So that's what example A looks like. All right, so we have a degree. They told us the degree is 3. So there are 3 zeros. The constant becomes the y-intercept. The number of extrema will be the degree minus 1, which is 2, so it's going to have 2 terms. The leading coefficient is 1, which is positive, so we're going, right-hand side goes up. The degree is odd, therefore the left-hand side goes in the other direction. So we have that information. Now let's put it on the graph. We know that this is going to cross the x-axis at -2. That's -2. And that's all 3 of the points right there. So it's going to cross at -2, -1, and +1. Based on the end behavior, the right-hand side goes up, the left-hand side goes down. It crosses the y-axis at -2, and so it must turn twice in the middle of all this. So there's one turn, there's 2 turns, and boom, there's the graph.